two properties for definite integral. The first one is sum and difference property. So this one is pretty straightforward. So you have an indefinite integral from a to b, f of x plus either plus or minus g of x. So you are adding two functions or subtracting two functions. So that one tells you that you can split that up into two integrals, one for each function. And then the constant multiple properties is even easier. You have integral from a to b, you have a constant times a function. So since this is a constant, it is not x, you can just take the constant out of the integral. So this is a constant multiple property. C is a constant. You can take it out before you integrate. So let's do a couple of simple examples. The first one is a definite integral from 0 to 3, 1 plus 2x. So I have a 1 plus 2x dx. So most people will just go ahead and then integrate 1, and then you integrate 2x, and then you do the fundamental theorem of calculus, right? But the sum and difference property says you can break this down into two integrals. So what if I change the 1 plus 2x to a 1 minus 2x? Then you change this to a minus. So we are adding 1 and a 2x, so we are adding these two integrals. If we are subtracting 1 and 2x, then we are subtracting these two integrals. It's pretty straightforward. Okay, let's do that. Oh, if you just evaluate this integral, the answer is equals to 12. So let's see if these two integrals give me a sum equals to 12. So the one is just an x, right? So it looks like I need to adjust my pen a little bit. So the antiderivative of 1 is x, and this is from 0 to 3. And then the 2x is x squared from 0 to 3. Pretty easy to check. If you take the derivative of that, you can go back to the integral very easily. All right, so this is equals to, the x is a 3 minus 0, right? And then the x squared is 3 squared minus 0 squared. So you have a 3 plus a 9. So 3 plus 9, which is equals to 12. So this is a 3 and a 9 equals to 12. So if you do this in one piece, you get a 12 as well. To be honest, every time I give out an integral like that on homework, quizzes, and exam, I have never seen people doing it individually. But this is some properties that you will have to know. But when you do your work, nobody do it in this way because there are too much writing. And then the next one, I use the same integral, except this time I multiply the integrand by phi. So phi is a constant, and you can take the constant out of the integral, and then you just do that. So the integral gives you a 12, right? So this piece gives you a 12, and then phi times 12, the answer is supposed to be equals to 60. So let's see what do you get for that. So I'm going to match the color first. So we have a phi. And then what else do we have? We have antiderivative of 1, that is x. This is x squared, right? And then this is where x goes from 0 to 3. And then this is, of course, in one piece. So we have a phi. And then what do we get? Plug in the 3, then you have a 3 plus 3 squared. Plug in a 0, then you have a 0 plus 0 squared. And then, of course, you have the big 5 times that. And then you have a phi, and then what do you get in the first piece? The second parenthesis is just all 0. So you have a 9 times 3, so equals to 12. 5 times 12 is equals to 60. Let's see how, do you see that, how easy it is? What is the benefit of taking out the phi? To be honest, I don't see that is not too helpful, but if you distribute the phi, that becomes of the integrand becomes phi plus 10x. I will see the only minor benefit is you can reduce the number down a little bit. Okay, you can reduce the value of the numbers, but do people do this when they integrate? I don't think so. To me, I would just do the whole piece. I won't factor out anything. But if I really want to reduce the numbers, so let's say you get huge coefficients, yes, you might want to reduce that a little bit. Okay, so let's take a look at the next problem. The next problem is pretty interesting. So you have from 1 to 8, 2 times a function plus 3, that is equals to 61. I am looking for the definite integral from 1 to 8. So what is that equals to? So this one isn't that obvious, right? Okay, so first of all, let's break down the given integral. So the given integral, we match the color first. So what do we get right here? So we have integral, right, from 1 to 8. So we have a 2 times f of x dx, and then we add integral from 1 to 8, 3, and then dx. All right, and then what else can we do? We can bring the 2 out. So we have a 2, 1 to 8, f of x dx, and then the 3, we can just take care of that. The antiderivative of 3 is a 3x, and then this is from 1 to 8, and then what is that equals to? This is like 3, 8 minus 1, right? So which is equals to what? Which is equals to 3 times 7, that is equals to 21. So what is this whole thing equals to? They said that the whole thing is equals to 61. So I just have a 61 equals to 2 times 1, 8 f of x dx, and then plus 3 times 21, right? So 3 times 21, that is equals to 60. Oh, okay, you know what? It's not 3 times 21. It's just a 21, huh? We got the whole piece equals to 21. So the whole piece is equals to 21 plus 21. So take a look. So we have a 61 times 2 multiply an unknown quantity minus 21. So how do you deal with this? So this is like 61 equals to 2 times unknown plus 21, right? It's like solving one variable with an equation with one variable. So 61 minus 21, so that is a 40 equals to 2 times unknown. Then the unknown quantity is equals to 40 divided by 2, that is equals to 20. So after all of this, so we have 20 equals to integral from 1 to 8 f of x dx. So this problem isn't that obvious, right? So that's why I picked this problem for our discussion. Okay, so that is the end of this video. If you like it, you like the way I teach, give me a thumbs up, a share, stay tuned, and I will see you all in the next one. Signing out.